Good afternoon, huge welcome to Eigen TV. Today we're so excited to have a chat with Adam Ballard from BP. Now Adam joined us a few weeks ago to actually talk about digital twins. So if you haven't seen that, you're able to find it on the Eigen TV YouTube channel. As we go through his discussion, as always, if you've got any questions at all, please do let us know by popping them in the comments below and we'll get back to you as soon as possible. I'm now going to hand over to Murray to kick off the discussion about robotics.
Well, thanks, Adam, for joining us again. It's been great to chat to you last time on digital twins, and I know we've got lots to talk about here on robotics. What I guess I'd like to kick off with is to give us your insights into where you think robotics brings value in digital today.
Yeah, I think just carrying on from the conversation last week on digital twins, I think robotics and one of the struggles with a digital twin is going to be, how do I ensure that real-time context, that real-time information on the system, where we've got transmitters, where we've got wired devices. I think those can provide that context relatively real time, whatever frequency we deem is good enough. But in areas where I need real-time understanding of what's on the deck, do I have room to put new equipment on it? Relatively real-time information that I would need if I'm planning a job, where I'm going to want to look at, the structure of that facility, and therefore what I'm going to need to do to be able to access and do the job I need to plan. I think that's where robotics could help. I do think it's going to be a balance between at least from what I'm finding, it's going to be a balance between, well, just put cameras everywhere, put microphones everywhere, put whatever other devices are everywhere. And so obviously, if that's one end of the extreme, the other end of the extreme is don't have any and put a robot with all that. I think the real value is going to come somewhere in between. And so that's the real challenge that I think we need to find, is where is that balance?
Yeah, and I think what was really interesting is that this isn't an all or nothing play here. This isn't a new Skynet from the Terminator film suddenly coming, the robots are going to replace all the humans. This is actually, or what you're describing where you've been involved, is looking for the opportunities to incrementally improve with a robot. So certainly to start with, you're not getting rid of any people. It's humans plus.
Absolutely. I mean, the messaging we're giving, and I think it truly is what we're working towards, is really to augment our technicians, and not just augment, but potentially even go beyond what they can see, hear, smell. But I've worked offshore for about 2 years and worked with our technicians in the Gulf of Mexico pretty deeply. And they are some smart people. Some of the smartest people in the company are on our sites. And to ask these smart people to walk around the facility to get readings from a gauge, to just make sure there's not a sheen overboard, and to just look at the equipment, I think isn't fully utilizing them. If we can get a robot to do those simple tasks, we can actually harness the power and the experience that our technicians can actually provide. So it's robotics, the area we're headed towards, at least one of the areas, is really about, utilizing the best of our technicians. And so not distracting them with kind of checking the box and just go gathering data, but actually spend their time focused on the data itself and really using their experience to understand, do we need to do something different?
And that to me is just a great example of where it's like the incremental gains, reducing the wasted, you're using your valuable resource for good stuff. And it's also, this is an area where actually things like AI can play a big part. You you've talked to me previously about the example of reading a gauge, which for a human is a very simple thing to do. But as you've said, you have to then pay someone to walk out and just go take a look. But this is a well understood problem with masses of data that we can teach with using computer vision as well-known libraries. Actually, we can apply this pretty quickly to do it. So the AI isn't making any decisions. It's just teaching it to read a gauge. It's then being able to do a function that otherwise is quite difficult.
Yeah, and I think you're touching on, you know, that incremental change, right? I mean, if we were to look at, you know, if we focus on the vision, right? If we focus on the vision and say robots will replace everybody, they'll be able to read gauges, they'll be able to understand what all the equipment is, and be able to basically do what a human does. And we wait until that is capable, until we have robots that are capable of doing that. I think we're going to be waiting a while. And so it is incremental, right? So and it just gets back to the approach we're taking, which is an incremental approach. I mean, you know, ultimately it will result in a transformational, disruptive way of doing things. But, you know, the approach we're taking is, well, step one, get a robot out there to walk the same steps that an operator walks. Step two, get a robot fitted with the proper sensors to be able to capture all the data or the information that a technician would do. Step three, and real quick on step two is, at a minimum, get the data to an operator in a remote location to actually then read that picture of a gauge. You know, listen to that compressor motor. Step three would be actually applying the machine learning and applying some of the analytical tools to actually read the gauge, listen for, and be able to tell if there's changes, right, to the system. You know, and so it's very much an incremental. There's obviously more and more steps, right? Is if an operator then says, that's an issue, here's what you need to do. Well, that's the next step to take, right? The next step is, how did you determine that when you heard a weird sound, you then took a thermal reading on that motor casing to see if there were hot spots, right? That's what you did. That's why you did that. And then start coding that up. I mean, it's kind of that digital twin approach, which is an incremental approach. Start with just gathering the data, right? That's the basics. Then get the robot to turn that data into information and find anomalies. Then it's about getting that robot to actually be able to determine what to do next. And that turns into a recommendation, right? And then I think, you know, that last area about actually taking action on it, you know, that's kind of that long utopian vision, right? And robots can then go out, and when it finds corrosion, it can scrape the paint, or, you know, and clean the surface and repaint and turn valves and do everything. If we're focused on robots, especially if we're focused on one robot that can do all that, I think it's going to be a long time coming. I think it will be the Terminators aren't coming, right? The perfect robot. In fact, well, I'll leave it there.
The Terminators ended up looking like humans,
which is pretty limited,
that was the
right?
best design.
Yeah. Well, that's not very humble, but absolutely, right? I mean, when you think about, and that's it just gets back to that approach, is because I hear a lot that, well, you know, we need to focus on what humans can't do, right? And I get it. But if you can't replicate what humans do, then it's going to be very tough to get a robot out there to do what humans cannot do. Mm. And so, at least when I think about that, it's about replicating what the humans do, and then it's adding new sensors, new capabilities, right, to go beyond. It's putting, you know, a hyperspectral camera on there that can see so many bands of that spectrum that a human can't, and seeing things. But those type of things, I think, are the additive. You can't start there.
Yeah. And also there's going to be an economic optimum for existing facilities, and it won't be to completely digitize everything and robotify the lot. I guess we're going to see a point where it makes sense to buy in capability from possibly robots, or as you say, installing a camera, or maybe installing wireless sensors like motes or LoRa, this new long-range low-power Wi-Fi and stuff. So instead of teaching a robot to read the gauge, you might just replace the gauge with a battery that lasts 5 years or something. But it will be, in each case, there'll be a sensible decision, and economics will probably just drive that quite simply. So there'll be a suite of options, and different assets will pick what suits them. But so if you were designing a new facility, though, that the robots that you design for a brownfield would be completely different from the ones you design from a new facility. I guess you'd take a completely different approach.
I'm still not convinced of that.
Okay.
I mean, that would be a good debate to have. And the reason I'm not convinced is we're building unmanned facilities today. And there are
don't
unmanned
even need a robot.
And that don't need robots. And, I don't see robots as necessarily an enabler for that, because the North Sea's got them. Many of our midstream facilities are unmanned. We've got facilities in Trinidad that are unmanned, and the robot needs to add incremental value to that. It isn't necessary, I would say, to build that and operate that. And I think there is incremental value to it, primarily in the eyes, the ears, especially if I've got a facility that I'm not going to plan to go out to but twice a year to do maintenance. Having eyes and ears real time. I mean, even a simple, I say simple, that's by no means meaning robots are simple. But even a simple robot that isn't autonomous, but I can remotely control it from onshore to an offshore remote site, or a remote site in the jungle that I don't have anyone at. I can get eyes and ears on that facility, and that's going to help me plan the materials and the jobs I'm going to do when I do go. But I think it's all going to be about that value, right?
Yeah.
And I'm not sure one use of a robot is going to add that value, to be honest.
So with the unmanned facilities, the biggest driver is the amount of time people need to spend on there, in terms of the size of the cost. And what you want to do is get rid of the accommodation block. Basically, if you can get rid of the need to have people out there overnight, even just one night, you could probably build a shelter. But what you want is really not to have to have to cater for humans on it at all. But you talked about having to maintain or inspect maybe twice a year. Is it such that there's a level that you can't design beyond, where you still need to allow for some kind of inspection in there, and is that where a robot could play? Or actually, is it possible to completely design the need for inspection? And therefore, I'll stop there with that question, because I've got another one. let's answer that question.
I think I'm answering the question you're asking. I kind of see this as, I mean, the inspection piece is a big one, right? I mean, that's a lot of hours go to inspection, and not formal inspectors necessarily, but even an operator walking around that facility, that is an inspection in the broadest sense. I think this is a kind of a triangle of technologies, if you will. I think new materials will require less inspection, right? You could design a facility with completely corrosion resistant materials. It would be expensive, but you could do that, removing the need and no flanges, nothing. I mean, it just, there's downsides to that, don't get me wrong. But, as one corner of that triangle, the other corner of that triangle is any inspections that we would want to do, we could just outfit it with sensors, right? That would be another extreme. And the other extreme would be, build them like they are today and just have robots go out and actually do all inspection, right? And I think it's going to be somewhere in between. I don't think we know enough about the robots at this point and the application in the industrials in the site to really understand about how close to that extreme, or is it the sensors? I mean, new sensor technology, as you said. I mean, I hooked up cameras around my house, which I've been holding off because I didn't want to run wire, right? And why did I finally do it? Because I've got a AA battery that lasts 2 years and they're completely wireless, right? I mean, the technology is getting better. Those will eventually be ATEX certified if the industry goes there.
Yeah.
And so I don't need to have roaming eyes. I can potentially just have constant eyes. So
that's right. And that's more cost effective. Yeah. It's very low maintenance. Yeah. So where I was thinking with the design of the robots and the facility is if you have a blank sheet of paper, you would design the robot and the facility together, much like we do with subsea. So you have an access panel with standard interfaces for the things that you do, and you decide it's not worth automating, because when you automate stuff, you've got more stuff that could break, more stuff that needs, the more you add complexity, the more likely you are to get a failure of something. So the driving something to, let's say, let's have motors on every single valve. Well, now I've got 60,000 motors on my platform. The probability of failure is now 1. Given the number I have, one of them is definitely going to fail. So you might say, actually, we're going to have super simple block valves. Say we're actually going to make these simple. They're going to be highly reliable, but we're going to have a simple key interface, and we're going to make corridors with all valves accessible. I suppose that was where my thinking was going, and changeable parts where you might say we're going to design it so you've got literally unpluggable whole modules that this robot or something can go get, and you put in a new one.
Well, and I absolutely, and I think, I mean, it's interesting you brought up subsea, because we've been doing this for years, right? And I'll tell you, the most reliable subsea system that I've ever been accountable from an engineering side to maintain, if you will. It was the temporary system we put underneath Thunder Horse when we had to redesign after we found welding issues with the existing equipment. So we ripped out the existing so we could repair it. It was going to take a good 1.5 years, and we had to design a simple, quick system to put in that would work. And that system had 0 automated or even remotely controlled valves. They were only controllable through an ROV. And it was one of the most reliable systems. We ran it for 2 years, and it worked exactly as designed. It was simple. We were able to fabricate it quickly. The testing of it was pretty quick as well, as you'd expect. There's not much to test. And it operated great, right? As opposed to the big manifolds we had, which had, 2 automated valves off of every branch. And you inevitably, as you said, I mean, the statistics are going to eventually make, something will fail, and so from a topside standpoint, I think we need to make sure we're looking at it from that mindset. That subsea mindset, which is, I've been an advocate for bringing in subsea engineers and designers into this conversation within BP, because I think it's that mindset that needs to be kind of grown from a topsides perspective. It's going to be easier to convert a subsea engineer, whether it be design or maintenance or operation of that subsea kit. It's going to be easier to have them apply that to topsides than getting a topsides or a facilities engineer to change over to that subsea mindset, right? And I think that's key. And I think the things you were bringing up are exactly the conversations we've had is, just having a standard panel where I lock in and it turns, right? And so it's one motor or one thing that is my point of failure. But I can have more than one robot to mitigate that, as opposed to having backups of all 60 motors, right?
That's right. Yeah, you'd end up with, and then you could have, instead of a crew quarters, maybe you have a garage. The robot sleeps in a garage, and you have a couple of robots, and then you just have to replace that one.
Yep.
From time to time if there's any issue, or just eject it. Get rid of it. But that's another thing, is the run to failure strategy. Then the whole idea of maintenance, one may decide not to maintain, I guess, and just make it easy to replace stuff if it breaks.
Absolutely. I think everything has to be up for debate in that space. If I have a robot, there's a give and take, as you said, between I'm going to maintain it to last forever versus I'm going to maintain it, or versus I'm not going to maintain it, let it run to failure and let the next one come through the corridor, right? I mean, I've got visions of the movie iRobot in my head, where you just load up and another one jumps out that looks identical, right? Quick download of everything this robot's gathered and learned and move on. So I think, and again, I think we're still trying to figure that out, right? Because the reality is, it's the environment's what's going to dictate that, right? A robot that's used inside a warehouse, an air-conditioned warehouse, is probably, if physics serves me right, going to be different than, from a maintenance standpoint or a failure standpoint, than a robot that's out in the salty air in the North Sea or in the Gulf of Mexico.
Yeah. Well, certainly when you get to design the facility from scratch, you can simplify the design of the robot, because you limit the number of tasks it needs to do. Then the challenge with a brownfield facility is it was designed for humans who are very flexible and quite adaptable. So you've got stairs and awkward angles for stuff. You basically need a robot that looks like a human, I guess, to do that.
Yes.
Or a dog. That's the case of Boston
or a
Dynamics.
dog, yes. Well, absolutely. And I think the more degrees of freedom you have, the better, the easier the solution comes, right? Because you can give and take off of both the robot side versus the design side.
That's right.
And my comment earlier around, not really convinced yet that it's a different robot, is I don't think there's been enough application in our brownfield to know really what those things are. There are some that are obvious. Do I really need stairs if I have, robots? Well, are you really going to design a facility with no stairs? Because people will need to go to that facility. How do they get around when they do need to do that maintenance? Or are you truly looking for the self-healing facility that never needs intervention from people? If you're focused towards that, I kind of look at it this way. There are hundreds of production assets for upstream oil and gas. There are hundreds of them around the world. Looking at kind of where we're going from an oil to renewable energies, are we really going to have that many more greenfield, brand new assets coming? Well, and is that really where we want to focus our attention, or is it the brownfield?
That's a very good question. So that brings me on to another angle for this, which is actually the time left to run of the industry with an appetite for these big projects, because that may actually not be enough to drive much investment in the area. If anyone's making a business case now for investment in offshore oil and gas specific robotics, probably difficult to get funding for it.
Yeah, I think, and which is why we've been focused on brownfield, to be honest, with an idea that, instead of going into a room or having a third party do a study for greenfield and how we build them with robotics, the approach we've taken is less academic and actually, I say it's less academic. It's less academic in the sense that I started with the hypothesis that we don't really understand how robots, work today in our industrial sites. What makes us think, with no learnings there, how can we actually extrapolate to a new facility? You mentioned you mentioned that value case. Is there really value with more coming, or not many new assets potentially coming in where the oil and gas business is going? Again, this is why we took the approach we took. And BP's got a very broad portfolio. I mean, we've got robots. When I came into the role as facilities technology manager, it historically had been for the upstream oil and gas production sites, right? And so I kind of took a broader perspective, waiting for someone to tell me, no, that's not yours, right? That's typically the way I approach things. Start big and kind of get beat back down to whatever box that I belong in. And no one ever beat me down, right? So I took a broad perspective that when we talk about robots from this team, it's going to apply at our wind farms. It's going to apply on our BP shipping, in our refineries, in our chemical plants, in our projects, right? As well as our production sites. And what we're seeing is actually that there's not a big difference between them. The capabilities of the robots may be slightly different, but the apps, if you will, that you need to put on those platforms are pretty much the same in regards to, it may not be that robot that I overlay this onto, this computer vision model or this algorithm to identify and classify corrosion. It may be a crawling robot, it may be a drone, it may be the spot robot, but that app needs to only be built once.
That's another interesting point as well, that the robots are really platforms, and there's apps that then enable functions on it, which is actually a really simple way of thinking of it. They're two separate things. You have your platform and you can kind of upgrade it with apps over time, and then those apps can get better and better at it. Because that brings me to another interesting thing that we can just chat a bit about on a thing, which is right into the detail, because you've actually built some computer vision stuff. And I think it'd be interesting for folks to hear actually, well, how do you do that? So could you just describe, just tell the story you told me of what you had to do? And you literally started from nothing, albeit being able to code yourself and being familiar with that sort of world, but never having done it before. What did you do? What was the scenario that you found yourself having to do it?
Yeah. So, and I'll briefly give some context on it. It was the context on it is we wanted a robot as a start to be able to read a gauge, right? And I had proposals from the team to do this, and what I couldn't understand is the one with the budget was, is that a good deal, right? Is it a good deal for the numbers you're telling me, right? And through questions that came up, I said, look, put in a very fundamental way or simple way is, can I go hire some kid from the local high school to do this in a weekend? Or is it going to take a team of data scientists 2 years to do, right? And didn't really get the answers that I was looking for that made me feel comfortable to spend this amount of money to do something that we didn't know how easy or hard it was. And so what we did instead is we created a little challenge within the team and said, all right, well, I'll tell you what, let's try and do this ourselves and see how easy or hard it is. And that was both, the approach I thought was as a good steward of BP's money here, right? But also I've always wanted to learn Python and I wanted to learn computer vision, right? I used to program. I'm fluent in 3 different languages, if you will, all programming languages. But I wanted to get Python. So, I learned Python and kind of went online through GitHub, just local, or publicly available or models, if you will, and built a model in about a week and a half, 2 weeks, that could read pressure gauges, right? And now I took a different approach than our data scientists. They took a pure machine learning approach, right? Where I don't tell it anything. I'm just going to, basically, mark up all these pictures and then teach the model. I took more of a of a logic approach in regards to, well, a gauge is typically, right, not all of them, but it's typically going to be round. And so let me look for circles and pictures, and let me zoom into that picture. And a needle is typically going to have a line, or be a line, and that line is not going to be, you know, more than the size of that gauge, and it's not going to be less than whatever number I gave it through trial and error. I think it was about 25%. And use basically existing, I would say, algorithms within the computer vision software, if you will, or models that were out there. I think it was like how circles and how lines is what I used, and basically cobbled those together to be able to identify the gauge, identify the needle. And then, you know, I found some OCR models and said, well, shoot, if I can understand, you know, all the, you know, the characters on here, let me do that, right? And so then I pulled all those in, I sorted them and filtered them for numbers, found the two biggest numbers and what spread that had. And then I knew basically the grading of that entire gauge. I knew where the 0 point was, I knew where my needle was, and now it's just simple, is it trigonometry, or, you know, sines, cosines to get from this quadrant to that quadrant, and blah, blah, blah.
Yeah, that's trigonometry.
But it was pretty quick, right? And so what I found is it demystified it for me, right? It demystified the computer vision. And it gave me an opinion, which may not be the right opinion. I'm by no means a 10-year expert in this space, but it gave me the opinion that the likely answer is probably a combination of machine learning and a combination of logic, right? It's very similar to what we talked about a couple of weeks ago on digital twin, right? I mean, within a couple of weeks, I was able to create a model that could read a gauge, and it took about a second to come through, which isn't good enough, right, for computer vision that needs to hit every 16th of a frame. But do I really need that here? Probably not. And so it's you know, and the value I could get from it right away, pretty quick, right, by using logic and some of the existing stuff out there. I don't need to build something brand new, right?
I think that's a terrific example. And actually, that's how even stuff like self-driving cars happen. That the whole thing isn't done by AI. What you're doing is you're using these well sort of trained AI libraries and you talked about how circles. So that's a well-proven library that's great at detecting circles. And it's a small enough defined problem that it's got millions of ways to do it. And it's been proven. So you can use it in your program language, just like a call. You just make a return count circles or something, and then you can return an array of all the circles in an image and work through them and start doing stuff. So you're using the AI to do the latest stuff, I guess, but you're stringing it together then in a sequential or a typical program way. Then it's just you're able to do more than you were before, and you're building in all your knowledge of the fact that I'm looking at pressure gauges here. I don't need to worry about differentiating stuff, although that raises an interesting question. To then deploy that, the robot first needs to find the pressure gauge to look at. I guess you've got a second layer of the challenge then in orienting it. But to solve this particular thing, you've already narrowed it down using your own know-how to say, well, we've only got certain types of gauges. They're either round or square. They've either digital or needles. So I just need to solve these two.
No, absolutely. And I think, look, I think this whole technology discussion that, you know, many are having, I think it all boils down to that. I think it's, look, I'm a subroutine type of guy, right? I'm a modular type of guy. And I mean, when I was building, you know, software programs, that was kind of the way I approach it. I want to make a solid subroutine here. And once I do that, it's done, right? I put it to the side, and it is either I turn it into a library, a DLL, and I only call it now because I know it will never fail. And if I have errors in my code or there's something wrong, I know it's not that. And you know, to help focus. And I think I think that's the approach that I took, and I think that's the approach to, if we want to capture value soon, quicker, and keep pace. I think that's the approach that needs to be taken. I think it's not about creating the next best Lego piece. It's about how you're putting existing Lego pieces together to build that structure that you want to build, right? I used to build spaceships back when I was a kid with Legos. We didn't have all the cool pieces they have today that have been made to, and they wouldn't rival the spaceships that my son builds. But you knew they were a spaceship, and they did the job for me. And it took that long to get new Lego pieces built. You could do it with the existing technologies today. We don't have to create a whole lot new. It's about finding the platform to be able to put all of these Lego pieces on. It's that green board, right? That's what you need.
Yeah, I think that's a fantastic point. That there is actually an awful lot. I've been around digital oil field for about 20 years now, and it used to be called the digital oil field of the future, and then lots of people had their own version of it: E-field, I-field, field of the future, and then it became intelligent operations. But it was really the same thing, but rebadged. And there's a danger now that digitalization, people might be getting stale and going, well, we've been talking about this for years. But I think it is different now because there is a lot of stuff available off the shelf now. Actually, the Lego box that you can pick from is much, much bigger than it's ever been now. And also we're seeing a lot of the stuff now in everyday life. This is no longer totally cutting edge, that the stuff you're doing in work has never been seen at home. Actually, now consumers' technology's moved on, and it's kind of expected. So I really think we could deliver it now. We could get that dream of fully integrated data, save money, efficient systems.
I agree, and I think I just carrying on from the digital twin conversation, because I see robotics as part of the digital, right? And it's about the approach. It's if and this is a frame we've used within the team, and it's more about approach and making sure that we're debating it, right? And it's just a simple picture, but it's about workflow, right? Is actually completing this workflow versus perfection in any given piece of that workflow, right? And from a digital twin standpoint, it materializes as, I need to get all of my data structured properly and accessible. And once I do that, then I'll work on actually doing something with it, right? And then once I do that, then the path to value is pretty far out. It's that $1 million that I'm constantly running after, and stepping over everything else. Eventually, maybe you get to it, but in the cycle time of projects and the cycle time of budgeting and reorganizations, therefore opinions, many projects like that never make their way to the end, right? You've completed that, but you never got to this, or you got 3/4 of the way through that, and they didn't see any value, so we cut it, right? No more. And the reason we looked at that frame with the team was it was really to debate, how far are we? Are we good enough? And making sure that we're actually working across that entire workflow. If I want, if I want to basically create a recommendation machine for compressor anomalies, I don't need to get all of my separator pressures, temperatures necessarily, structure, all that data structure. I need to get all the relevant compressor data structured. Now, somebody say, well, but all of that data is relevant. You're right. It's probably tertiary at best, right? I can get 80%. This data is good enough to then move on to, now I need to flag anomalies from that data. Look what baselines look like, and identify, okay, that third step is, now I need to get all the relevant compressor design data in, get my cause and effects in, get my maintenance data on those compressors. Not all the maintenance data, compressor maintenance data. And then I can start cobbling together using rules and logic, right? Something that recommends, based on an anomaly, what I should do, what it could be, and what I should do based on that. I see robotics as very similar, right? If we wait for, and here's a good example, an ATEX certified, intrinsically safe robot to even put a robot out at our sites, we're going to be waiting a long time, waiting for the perfect robot, which may come, and there are some out there, is not going to get you ahead. You're better off, in my opinion, taking what you've got and then starting to overlay, as we said before, now go get me data, right? Make sure I can hook a sensor to it and it feeds back to me. Now let me make sure I can process that data and do something with it, identify anomalies, and then, continue and continue. Waiting for it all to come together before I ever put a robot onto a site, you're missing out on a lot of learnings, right? I mean, it's optimizing the components is not going to lead to an optimized outcome.
No, that's completely right. And how is it going to come together unless someone does it? What you're really saying is, well, we'll do nothing and we'll watch everyone else do it and then hope we can jump in at the end and catch up. And it doesn't work like that. And we're in danger of preaching to the choir here, because having been through so many projects where these aren't well-known projects, a lot of the times it's the first time something's being done. It's extremely difficult, and in fact, it's impossible to accurately define the extent of it up front. So to the classic question, well, surely you can tell me how long it's going to take and how much it's going to cost. The honest answer is not really. It's actually very complicated. The only way we'll know exactly what needs to be done is to have done it once. And so rather than sitting in a room and trying to theorize, you're far better just getting out there and figuring it out, because for sure there'll be stuff that comes up that you never thought of in the room, but also what turns out to be the really difficult stuff is not what you expect either, like the Daleks going upstairs or something. It'll be something apparently simple that you suddenly realize is extremely difficult to deal with in practice. And you just got to get going. Yeah, I completely agree.
Yeah, and yeah, I mean, look, there's all kinds of futuristic scenarios we can have, right? I don't need a robot that can climb stairs. I will have a robot that can deploy a small drone to go do that inspection for me when it runs across it. That's great. But to be honest, I mean, if we're working towards a robot that can deploy its own drone and then communicate and get that information back to it, that's great. But if you don't have a robot that's taking care of the rest of the 95% of your site, then that effort, in my opinion, is a bit too early, right? Get the value from the robot now. Your focus should be on getting what you can do today, getting the value from that. And, and I think, I can't speak for everyone. And I think the different companies are in different spaces, but I think that's a key thing that needs to change in general, is getting these things out there that are good enough. The robot technologies out there are good enough. Could they be better? Absolutely. How are they going to get better fastest? By using them and actually having real feedback loops on how to modify the designs or some of the software on it. But theoretical loops aren't necessarily leading to a better outcome or a better machine. So I agree.
Yeah, great point. Maybe others will disagree, and I'd love to hear from you if you disagree. And it would add spice to the debate, because I'm sure there's a viewpoint, and certainly for safety things. Although you had a very interesting point about inspecting a flare stack. Actually, a robot's a perfect candidate, because you don't have to isolate all the safety systems. If you're inspecting it and the flare happens to go off, you just have to write off a robot. But it's still cheaper than shutting down production in order to have a human do it.
Absolutely, especially when you look at how many isolations you'd be making. That can be, depending on the size of the facility, that could be a week's worth of work just doing those isolations, and the de-isolations that follow. And back to the statistics conversation, if error happens at some frequency, the more you do it, the more likely you're going to have an error. So are all those isolations in place? Are they all now, free to flow in the event of a safety incident to your flare header? Or did we miss one, right? We did 1,000 of these things. And that adds to that time, right? Which is why it takes so long. It's not just around jumping around, flipping valves.
Yeah.
So
where do you think we are, Adam, in terms of value that robots can deliver right now?
So I think, just based on the experience we've had in the last couple of years, it feels like there's a huge gap between the robots themselves and the value that's actually gained from them. And that gap, to fill that gap is a lot of freaking work, is what we're finding, right? The robots, when they show up to your site, are not out of the box ready to start doing everything you want it to do, if any of it, right? And it gets back to this app piece, is they don't have the apps for the applications that you want. And that's what we're finding in BP. And one of the reasons we took the approach we took, it was to put our own resources on this to really understand what it's going to take to bring all this together. Anything as simple as, and I say simple, it's again, not simple, but anything as simple as simple as, let's say I've got 5 robots. How do I manage those 5 robots? Is there a common software that I could manage all of them, right? Because as a user of these, I'm going to have to be trained, have trained people to be able to maintain, to operate these robots. What about, so as a little more clarity or definition of that gap, I think there are a lot of those. This kind of gets back to this Lego analogy. I think all the Legos exist. There are computer vision algorithms out there. There are companies that will provide them for you. Many companies can do them with internal resources. Those Lego blocks themselves add no value. I have to then apply it to a robot. And, there's lots of questions that still need to be asked in regards to that. About how do I apply it? Do I put it on the robot? Do I put it in the cloud? Do I put it on my local server? What's the bandwidth needs? And those are the things that we're trying to figure out now, right? And we've got, BP's a big company. We've got a lot of resources to do this. And so we're able to figure out, what needs to happen in order to be able to take this robot and put it on my site and it's off doing what it needs to do, right? Right now, many of the robots, can learn an autonomous route, whether it be learning itself after you walk it, or show it, or putting a line down to do it. But if I've got a 3D twin of my facility, how do I get it to actually, me be able to push a button and say, go to that compressor, and how, and in order to get it to know where that is before it's even walked it, right? Stepping onto the facility and adding value immediately. When you start thinking about scaling these up, those are the things that need to be looked at and thought about. And I haven't seen necessarily anything in the market at this point that doesn't hit maybe a few of those blocks, but it's still on us to actually bring them all together. Well, a lot of these smaller operators don't have teams, and a lot of these, not just oil and gas operators, but even, in downstream or other industrial sites, they don't have the resources to be able to bring all that together. So I do see that is a gap that needs to be filled somewhere to basically make these robots, when they do, both, on their way to the site, can kind of get that download and are now smart and can actually go and go on missions. So,
well, fantastic to chat. I'm aware that we've already talked for a long time, and it's a big subject. But I'd invite anyone who's watching this and has any thoughts, please get in touch and comment. I know Adam has an absolute wealth of knowledge in this area, and we'll be delighted to chat more about all kinds of stuff. And I look forward to talking more in the future, Adam. Thanks very much.
Thank you.
A huge thank you to both Murray and Adam for such a wonderful conversation on robotics. I hope you enjoyed it as much as I did. If you've got any questions at all, please feel free to pop them down below in the comments. And as always, we'll get back to you as quickly as we can. But in the meantime, stay safe, keep well, and we will speak to you very soon. Take care.